Hello and welcome to the C++11 Beginner Tutorials by Gamer2Creator. I'm Chris. So in the last video I showed you where you can get your documentation, showed you a book that you can get, stuff like that. That will be very useful to you in the future. Now I wanted to suggest that you get a second monitor. It's not a requirement, but it will really help you. It'll save you from a lot of headaches. I know some people are on laptops, and that's okay. But if you're on a desktop and you can, get a second monitor. Now, you could probably find a cheap one on Craigslist, a used one, and it doesn't have to be a good one, because all you have to do is be able to read text on it. Now, the reason why you'd want to do this is so that you can have your IDE up on your main screen, and your documentation up on the other. Now, if you can imagine yourself reading documentation, a lot of the times you'll be wanting to read from the documentation and write code at the same time, and you can only do that with two monitors. I mean, sure, you could split it maybe half and half, but as you can see, that doesn't leave very much space. Now, if you get a second monitor, that will help you be much more efficient, and it'll save you from some serious migraines. But again, it is not required. And with that, we're going to start talking about strings. So, in order to get access to the std string, we had to include the string header between the left and right arrows. Now down here we have our string. Now real quick, as I mentioned in the last video, this is actually a type def for an std basic string. That just means that someone has given this, using the type def keyword, another name. And they gave it the simpler name of just string. But it is actually called basic string. So you need to know that if you're looking through documentation, because they might require you to use the real name. Okay, so we've created our string. We have an example here, stir example, and we've assigned it hello world. Now we've done this before, as I quickly showed that you could do this with strings in previous videos, so that we could show you some examples with some meat tool. But we're going to talk about what else we can do with strings. Well, we can concatenate using plus equals, and then we can have another string here. Now to prove to you that we can do this, I'm going to cut that part out of that string and put it on this part. And what this is going to do, first we initialize our stir example here to hello. Then we use the plus equals operator to concatenate this string, space, world, and then the period, onto this existing string. So it's going to add this to whatever was in this when we got to this line. So let's see this in action. So we can see, now that we're on this line but have not executed it yet, stir example equals hello. And we can look at the buffer, and there's the HELLO. Now on this line, it's going to add this string to hello. Now as you can see, it's hello world. Now, if the buffer wasn't big enough, the underlying buffer that the string maintains, if it wasn't big enough to hold our hello world here, plus the hidden null terminator, then it will create an entirely new array, copy the old contents onto the new array, and then add the new stuff onto the new array as well. and it will make sure that it's big enough to hold the new string. Now remember that this string actually has a null terminator in it, and that this string actually has a null terminator in it. But the string class is smart enough to overwrite that first one. As you can see, there isn't a null terminator here at the end of hello. So it's important to know that it's smart enough to not include that null terminator. It actually overwrites it with the first character of the string you're concatenating. And to prove it to you, we can even look deep inside this string at the buffer. And you can see that the only null terminator is down here at the end. So that's concatenating. Now we can also make another string variable, and we'll call this str example world. We'll assign this to space world with a period. And instead of just doing this literal string here, we can actually use our variable. And it will take the value of this string and can concatenate it onto str example. Now, because we use plus equals, that means add to this one. And we're going to print this out. And it should print out hello world. There we go. But if we used plus is different. And it's the same idea as when using plus for integers or plus equals for integers. That plus does not modify either one of these variables. Instead, it returns an entirely new variable with the result of these two concatenated together. Now, in order for us to do something with the string return, we need to capture it, put that into a variable that we can use, and then we can print it out. Now this is going to also print out hello world. Now to prove to you that this is the way it works, we're going to print this one out. Now because of what I just told you, these two are not modified. Instead they return, because of the operator, a new string. So this one should just be its original value of hello, and we're going to print that out. And there you go. Now, here we've taken this temporary string that plus returned and stuffed it into a named variable. But we don't have to do this in all situations. Sometimes that we don't need to store the concatenated string. So if we wanted to print it out, we could actually do this, and to make it more clear, we'll use the parentheses. And so it'll do what's between these parentheses first. And what it's going to do is going to take the value of this and the value of this, create a new string, and add them together and stuff it into that temporary string. And that's what will be returned in the place of this. So it's going to print out hello world, because the temporary that exists here after these two are added together will be printed, as you can see. So we didn't have to store that result string that we did earlier. However, it's not any faster, because it is a little bit faster because we created the temporary and then copied it into the string result. But here, we still created that temporary. So this doesn't save a whole lot of speed. Alright. Now what we're going to do is show you some of the methods and things that you can do directly with a single string. Now, because a string is an array of characters, you can actually access them by index. And we can print this out. Just to prove it to you. Let's comment this out. So it's just going to run this count. This count doesn't exist anymore. I'll just delete it. Hell, it's one line. So we're going to print out the very first character at index 0, a stir example. And this should be a capital H. And there you go. Now we could even loop over our string. And remember that I is sort of a semi-standard. Pretty much everyone uses I for an index within a for loop. Now, how many times are we going to want to loop if we're going to loop over every character in the string? Well, it's simple. Stir example dot size. This is just a method call that happens to return how many characters are in this string. And not how many are in, how big the buffer is, but how many we're actually using in our string. So if we look here, well, let me finish writing this. Plus I. So it's going to print each character out on its own line. And since this returns size, if we go to right here, and it'll tell us how many characters are in the string, we have size of 12. So it's going to loop over this 12 times, and since we use less than, the highest number that is valid is 11. Since it's a zero-based index, the highest index is 11. So this should print out, and I'm just going to continue it. Hello world on each new line. Now we can take out the new line. We don't have to print things on a new line. And it'll actually print out hello world. So there you go. We've actually accessed each character in our string using an index and a loop. And we've printed out each character within the string. So you can use this to solve some problems. Now there are other things we can do. Stir. If you type in the variable name and dot, then you can use Microsoft Intellisense to see all of the methods that are available to you. These are, by the way, the same ones that you will find in our documentation. And I prefer I think it's this one. Or was it the other one? No, not this one. I prefer this one. So we'll go to string. And then here we can see all the methods and get their descriptions as we covered in the last video. But real quick, you can actually push the dot and see them here, only you don't get the descriptions. There's no real good explanation of what they do, so that's why the documentation is so important. Now we can do back, which returns the character at the end of the string, but not the null terminator, the one before it. We can use at to get a character in the string at whatever index you wish, which is pretty close to the same as using the array index. We can clear the string. I was picking on this method earlier. in the documentation video, this will clear out all the characters in our string. I'm going to prove it to you. You can see here that stir example has a size of 0 and the value is empty. There's nothing in between those double quotes. But our capacity is still 15. This is because clear will not empty the buffer. It's not going to free the buffer. But the buffer will be freed when this variable falls out of scope. Let's see what else we have. We have empty. Here's another good one. This returns a bool. Now you can do an if check here. If my variable stir example is empty, meaning there's no characters in our string, then we can do some code here. Now what we do here could be anything. It's up to you. But if it's empty, you would do code expecting empty string. And then we can else it if we wish. This is optional. Do code expecting a non-empty string. And this is how you would write code if you were checking to make sure whether or not string was empty. You can also flip this using a not operator, which we haven't covered yet, I don't think. We have covered not equals, which is partly a not operator. But what it'll do is it'll just flip the Boolean value, and then everything is reversed. But you don't need to use it because then you can just use else. That is entirely up to you. So now we have clear, we have empty. We can get characters in and out using index. You can get the capacity. This tells you how big the underlying buffer really is. Not how many characters you're using in that buffer, but how many characters wide the buffer is. You can get a C string. Now, we've talked about C strings. They're null terminated strings. So they're an array of characters that are terminated or ending with a null terminator. Now this method will actually return a constant char pointer, and I'm just going to call this P string for pointer to a string. And some people would like to be C string, since it is a C string. And we haven't really seen this syntax, and we haven't talked about constant very much. But just know that I've here declared a char pointer. And that is what C string is. It's a pointer to an array that is a C style string. Now, often because string, this class, has all these nice methods and functionality that you can use, you'll want to use it as much as you can. You'll want to use its concatenation features and access features and all this good stuff. But then a lot of libraries like to take in C strings. If you're passing them strings, they want a C string, which would be a constant char pointer. And you can get one of those that is a representation of your string using this method call. And you know what? I'm going to show you an example of this. You don't have to understand what a char pointer is just yet. Function that expects C style string. And yeah, that is a very long function name, but it is descriptive, and that's always a good thing. And then it takes in a constant char pointer P C stir, and then we can print out our C string using count C stir and line. Down here, we're going to call our function that's expecting a C-style string. In the parameter list, we're going to do stir example, because this is our string, dot C str, and that's it. This method is going to return a constant sharp pointer. It's going to copy that pointer and send it into this function. In this function, it's going to use that pointer to print out our C-style string. So first we're going to run through it at real speed, and you can see that it printed hello world. This time, we're going to actually watch it execute. So here we've already initialized our hello world string. We're about to call this method. This one, because this has to be evaluated before we can even call this. So this is evaluated. We're going to step into, and here this is the name of the method. Now this is deep into the STL code. You don't need to even be able to read this stuff, but you might be able to. And we're going to step over this, and now it's returned our C-style string. Now we're stepping into our function that expects a C-style string. And you can see that this pointer actually has a value in hexadecimal. And it actually even says here, hello world. And then here, count has an overload for a C-style string. So it knows what to do with a C-style string. And we print it out. Now, I'm pretty sure you're probably complicated by the C-style string thing. And this requires knowing what a pointer is, which we will cover soon, but not yet. I'm going to save pointers and references for a later time. And so this is the end of our application. So that's a pretty good introduction to string. And like I said, all of these methods do something, and you can look them up in your documentation. We haven't really covered iterators yet, so I don't want to do that. But I do want to show you what pushback and popback do. Popback removes the character from the end of the string and not the null terminator, the one before it. Pushback pushes a character onto the string. Let's do, just to make this easily see, X. So here we're gonna add X to stir example, and I should really say pushback, not add. And now when we run this, it'll be hello world dot capital X. And that's what pushback does. Now get familiar with this pushback, popback type functionality, because it's repeated across many classes in the STL, mostly related to data types. And then here we can do stir example dot pop back. It doesn't need any parameters. And then we'll print it out again. And when we do that, the X will be removed because we pushed it onto the end and then we popped it off. As you can see, it's gone. Now, let's just see something. Okay. And that's all I'm going to cover about strings. We're going to cover some more of the STL in the next videos. I'll see you then.